All right, now problem 10 was a question that you really had to think about. So if you got this, you should be proud of yourself. All right, so we're talking about a dihedral group, which is a symmetry group of an n-sided polygon. It has the following properties. First, Dn contains counterclockwise rotations of 72 degrees. Okay, so something special about 72 degrees. Second, Dn contains a reflection which fixes two vertices of the polygon. All right, and then number 3, Dn contains less than 30 elements. Okay, and it says find n and explain your reasoning. All right, so first of all, let's consider this 72 degrees. Now, what's special about 72 degrees? Well, it's less than 90 degrees. It's bigger than 60 degrees. What's going on here? Well, you should notice that 72 is equal to 360 over 5. Okay. So what does that mean? That's 1/5 of a full turn. So Dn contains the symmetry that's 1/5 of a full turn. Now that would seem to indicate that n is 5, because you have 1/5 of a full turn, and you would think that that would mean you have a pentagon. But unfortunately, that's not possible, because there's no reflection of the pentagon that fixes two vertices. If you look at all the reflections of the pentagon, they only fix one vertex. And if you go back to the discussion in the book, let me see if I can find that. The discussion of reflections in Dn, well, there's several exercises. You could see by example that the polygons that have an odd number of vertices, all of their reflections fix only one vertex. And the polygons that have even number of vertices, some reflections fix no vertices and some fix two. Right. I'm not sure if that was stated explicitly here, but you could get that from the examples that we have here. So this tells us that in fact n must be even. N must be even. It can't possibly be odd. So how can n be even and still contain this symmetry of 72-degree rotation? Well, this is what you have to think about. If the polygon had 10 sides, so I'll just draw it like this. If I had a 10-sided polygon, then a 72-degree rotation would correspond to moving two vertices over, which is still a symmetry of the polygon. Right? If I had a 10-gon, then 72-degree rotation would take this vertex to this vertex, and it would take this vertex to this vertex. I'd still have a symmetry. So n equals 10 is a possibility. Now, are there any other possibilities? Well, if I'm going to have the polygon preserve this 360 over 5 rotation, then the number of sides should be a multiple of 5. So the even multiples of 5 are 10, 20, 30, etc. All right? So from the first two facts here, we've narrowed n down to be one of these, 10, 20, and 30. All right, now how about number 3? Here it says Dn contains less than 30 elements. Now, how many elements in Dn when n equals 10? Well, here you have to think that if you have a 10-sided polygon, there are 10 rotations and 10 reflections. So this is 20, right? For a 20-sided polygon, you have 20 reflections and 20 rotations. That's 40. So that doesn't work. 60 similarly doesn't work. The only possibility is n equals 10, and that's how we narrow it down. So that's the answer.